Hi, I'm course squad 11 and 5 from YUMIN Primary School. This lesson is Differential Equations, Chapter 1, Separable First Order Differential Equations. In the past, we've learned a lot of these differential equations, but one thing we have never done is to put them into real-life things. What I mean is that we've never done any applications. So for this time, we'll have our first application. So for this application, it is actually that a radius of this circle, it increases at a rate of 3 cm per second. And do you know what this means? This actually means the starting radius. The initial radius is 1 cm. So that is the question part. Next here is the part that we need to find our answers. So first, we need to find the rate of increase of the area. Remember, it must be the rate of increase of the area. And this is when the radius is 5 cm. So this is one of them. The next, remember, still the rate of increase of the area. When the area is actually 4 pi centimeter square. That's the next. Then the third, we actually just need to find the area when the time passed by is 50 seconds. And the last part, we need to find that circumference when t is 100 seconds. Which means 100 seconds pass by. So, for this circle as an example, we can have A. Remember, A for area, this is pi r square. Pi r square, well, first here we can have dA dt. A is a function of r. R is actually a function of t. So A is for this A is actually, I wonder what function it is of t. So this actually, it is not able to be seen. At the same time, it is also not able to be written out. So for this kind of function, we call it implicit function. So like this. So for this, remember, implicit function, we can also call it composite function. So actually for this, what if we actually add a bracket for this dA dt? Well, this is the, guess what this is? So this is what we call it the dimensional analysis. For this dimensional analysis, by looking at the name, don't just think that it is about learning about these dimensions. This is actually, the dimension is actually units. So it's actually units analysis. Well, we just call it this name. So that means we must be very careful about all of these units. So this first part, remember, the radius is from 5 cm. We need to find that rate of increase. So for this, dA dt. Remember, we must use the chain rule. So first we'll differentiate this, the pi r square. Remember, it is r. So this is the 2 pi r. Well, but how about the r? Easy. dr dt. So for this, well, 2 pi r dr dt. So we want the radius to be 5. So here can be just 5. So 2 times 5, 10 cm. Then for this, remember this we'll need to r equals 5. So dr dt, well, that is actually the increase of the radius. So that is the 3. So this is actually 30 pi. Well, what is this actually? This is the cm square. Remember, because this is the area. This is a cm square. But remember, rate of increase. This means per second. You can also write it as like this. These two ways, they have the exact same meaning. It doesn't matter which way you use. So this is for the first part. So for the next part, we still need to find what is the rate of increase of this area when this area is 4 pi centimeters square. So for this, well, dA dt. Well, actually, we don't use this. So for this, part B, this is when we're given that area, which means pi r square, it is actually 4 pi. So what is r actually? Let me just tell you, r, this is 2. Then, at this time, and remember r is actually cm, then at this time, we'll use the dA dt. So for this r, at last we get 2 cm. So for this 2 pi r dr dt, we'll set r equals 2. So 2 times 2, 4. 4, but remember about this 3. So which is actually a 12 pi. Which is actually like this. Okay, so these are the first two parts, A and B. Next we can have part C. Remember part C, we'll just need to find the area when 50 seconds passed by. So when 50 seconds pass by, remember, each second the radius increased by 3 cm, 3 cm, 3 cm. So for this radius, at last, which is actually, so we can write it in that definite integral remember, dr dt, which is 3, we'll actually just need to solve that differential equation. Remember, best is to use definite integral. If you use indefinite integral, also can. But at last you just need to find out that C. So, t from 0. Obviously, time starts from 0 here. So when this is 0, this starts from 1. So time, when does it end? It ends at 50 seconds. Or we just write it as it ends at R. So we just need to solve this. So here is just an R. But remember, here -1, move it to the other side. So for this, we'll have 150 plus 1, which is actually a 151. But remember, it doesn't just end here. We'll need to find what is the area. So this, you need the 151 square times this pi. But what is 151 square? Well, for this, which is actually, you can just working calculate it out. Is a 22801 pi. Remember, this is the area, so this is cm square. Okay. So this is our answer for part C. Next, part D. This time we need to find our circumference when t is 100 seconds later. So 100 seconds later, it's actually something like this. The dt is always 3 seconds because this increase, it just keep increasing 3 cm. Yeah, this is cm. Remember, 3 is actually a constant, so we can put it outside here. So here when it is 0, here's 100, still r. So for this, r is actually just 301, and remember this is actually the cm. So for this A, so circumference we'll just use L. But remember, to find the circumference it is 2 pi r times 2. And don't forget the pi. So this is actually cm. So it's actually just like this. For the first application, it is just this simple. Okay, so, well, that is actually all for this application problem. Well, remember in the future, our application problems, they get harder and harder. So this is when we use our ordinary differential equations. So that will be the end for this lesson. So we'll see you in the next lesson, and don't forget to subscribe to our channel if you like our videos. So we'll see you in the next lesson. Thank you for your watching.